Morning, people. Are your fingerprints unique? You are the only person with fingerprints like yours, but your fingerprints are more alike than you think. But why? The answer may contain science. Forensic fingerprint analysis works in court for the same reason that your smartphone unlocks with a finger, on the presumption that the pattern of loops and whorls on your finger is unlike anyone else's. Fingerprints are a lot like snowflakes in that if you could ever perfectly recreate conditions, you could get a matching snowflake or print. In practice, that never happens because there are simply too many environmental variables at play in snow clouds to ever exactly match them. And it's likewise with fingerprints. You get your fingerprints in utero, and they're formed as different layers of the skin develop at different rates, causing those layers to rub up against one another and create ridges. Genetics plays a role in that development, as do blood pressure, blood oxygenation, hormone levels, parental nutrition, amniotic fluid composition, density, pressure. All these factors contribute to just how your fingerprints form, and just like you're never going to exactly replicate a storm to produce an identical snowflake, one person's development will not be so like another person's that their fingerprints are identical to yours. Even identical twins, who otherwise share all those genetic and environmental factors, still don't have identical fingerprints, because even the position of the fetus in the uterus affects fingerprint formation. But a new discovery in scientific advances shows that while my right index finger's print won't match any of your fingers, my right index finger may match my left, or my middle finger. Apparently my thumbs might be most likely to match each other according to this data. Why do they match, and how did we figure this out? Well, if we think about development, we were just talking about, it makes a certain kind of sense. Just like twins don't share every environmental factor, neither quite do each of your fingers. They're each positioned a little separate. They're different sizes, but they're the closest anything's ever going to come to identical conditions, the closest. Even so, we've never been able to use that to match fingerprints. If I try to unlock my smartphone with my left thumb, but I trained my phone with my right thumb, it doesn't work. Likewise, if I hypothetically left a latent fingerprint at a crime scene, forensic science would never be able to identify me unless they had a print of that particular finger in their database, so why no match when doing crime? It's all about how we find fingerprint matches. Each print on your finger has minutiae. These are key points where loops change or lines split or sweat pores interrupt your ridges, elements that are absolutely unique to that print on that finger. Identifying and comparing these key points is the fundamental technique that underlies fingerprint identification in forensic science and in your phone. And unlike a bunch of those old school forensic methods that turned out to be garbage, comparing minutiae for same fingerprint matches is surprisingly reliable. In 2011, 169 experts compared 100 prints each from a pool of 744 pairs. The false negative rate was 7.5%, meaning a true match was occasionally reported as not a match, which in most cases would lean toward finding someone not guilty. By contrast, the false positive rate, the rate that finds a match where there is none, was only 0.1%, 1 in 1,000 print comparisons. My defense lawyer will still do what they can, and experts are judged on their individual reliability, not the accuracy of the field as a whole, but as evidence, fingerprint matches based on minutiae aren't like debunked hair matching evidence or anything. And your smartphone's unlock or the automated fingerprint identification system used by law enforcement to catch my alleged crimes most often use the computer equivalent of what that expert does. Most systems computationally process an image down to its minutia, then compare it to the training you gave your phone, or the fingerprint record database, if you're doing crime. If this seems like something that computer image processing is good at, it'd be absolutely right. With the best automated fingerprint identification systems posting false positive rates of 0.1%, as low as the expert examiners, and a false negative rate even lower at 1.9% in one test sample of 30,000. Because we focus on the minutiae, the elements unique to a single finger, all of this means that we've gotten incredibly good at answering, are these two prints from the same finger? But what we really want to know is, are these two prints from the same person? And that's where this paper comes in. The innovation in this paper is strikingly simple. What if we measured something other than minutiae? After all, those are specific to that finger, but there are other variables, from density between ridges to where each ridge changes direction. And when these techniques were first developed, they didn't have what we have today. Deep learning algorithms that find connections we don't naturally find. And when computational similarity analysis is applied toward different fingers, this paper shows that for the same person, those different fingers are pretty darn alike. Here's a preview of the similarity, and supplementary materials show the results are statistically significant. Similarly sized fingers show particularly strong cross-finger similarity on the same person, with comparisons between pinky fingers and thumbs or middle fingers being marginally less alike, which makes sense. I can imagine finger size affecting pattern. But across the board, this finding challenges what was previously thought, to the point that Science Advance's editors rejected these findings at first pass. These findings cannot be. Each fingerprint is unique. That's still true. But this study shows that fingerprints can be unique while still being similar enough to identify. That said, this study does a good job of analyzing what its model can and can't do. In particular, these researchers open the black box to interrogate the results and learn a little more about how their algorithm reached its conclusions, a step that is all too easy to skip with these models. They also tested demographic subsets of their data to determine whether race or sex affected intra-person finger similarity, which is inestimably important given the forensic and criminal justice implications of this technique. In deep neural network training, it's garbage in, garbage out in terms of training data. And official use of algorithms has wrought havoc when training on demographically skewed or inappropriate data sets. Indeed, this study's authors do find that although the model worked best when training on the widest data set, surprise, surprise, when training demographic subsets, there were differences in performance in terms of finger similarity across demographics. That's a crucial thing to figure out before you put models like these into practice. And although the wider dataset does seem to have good distribution, I'm happy to see these tests were worked into the very first finding in this line of inquiry. So the question is, your fingerprints are kind of alike. How much does this matter? Well, if you unlock your phone with your finger, you may someday be able to unlock your phone with fingers you didn't train your phone on, but that's hardly the most impactful outcome. More importantly, will criminals be forced to curtail our wicked ways? Can law enforcement identify my fingerprint on the scene when they only have a record of my thumbprint? While this model may be used to identify more promising leads, the fruits of these findings are unlikely to show up in court anytime soon. Beyond reasonable doubt is a high standard that this model doesn't yet meet on its own and will require significant reliability testing as required by many criminal justice systems. So, in the meantime, rejoice! You are still unique, even if your fingers are more alike than we thought. And as for crime, well, don't do anything I wouldn't. Don't get caught.